Good evening to all. Am I audible to you all?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, you all can give your attendance by writing your name and USN quickly. Okay, we'll start the session. It is a dimensional analysis. We were discussing about dimensional analysis. Is it visible to you all, right?
Yes, sir.
Yes,
Okay.
sir.
Right. So we'll repeat it once again. Yesterday it was some problem in slide movement. So we'll repeat whatever we have discussed previous class regarding dimensional analysis. We'll repeat the same thing today also. So as I was discussed about the objectives of dimensional analysis. So dimensional analysis is the first module of this applied hydraulic subject. It's a mathematical technique which is used to analyze the problem, that is definition of dimensional analysis. So dimensional analysis is a mathematical technique in which the use of dimensions, so it's very, very important. It's a mathematical technique in which the use of dimensions of different parameters of a physical problems. Different parameters means physical quantities. The parameters means physical quantities. So can you tell what do you mean by physical quantities?
Any quantity which can be measured.
Yes, any quantity which can be measured is called as a physical quantity. Like area, volume, discharge, length, mass, weight. So these all are called as a physical quantities, or we can call it as a parameters. So as the definition of dimensional analysis says, it is an mathematical technique in which the use of dimensions of a different parameters of a physical problem is used as an aid to solve many engineering problems. Many complex problems can be solved by using the dimensional analysis. And means suppose where some scientists they rely purely on theoretical investigations, where it fails to get the solution, then they go for the experimental problem. In that, to arrange the experimental setup, then they use the tool called dimensional analysis. Dimensional analysis tells the researchers how the arrangement can be done, experimental arrangement can be done, it tells. So that is what we call as it's a mathematical technique which is used to solve many engineering problems. And even this dimensional analysis tool to be used for the model investigation. Model investigation, again I'll tell you what are model and prototype. Suppose for example, if you want to construct a dam, that is as a hydraulic structure, so directly you want to go for a construction only. Before that, you do certain studies, then you make a model of that dam and you will test in a laboratory, and that too smaller scale dam, you will be making a model of that particular structure, and you will be study that entire structure, then you go for the construction. But for making a model studies, certain parameters to be studied, then how to study those parameters, that will tell by a dimensional analysis. I hope you understood this concept. So for making a model investigation study, you have to have a knowledge about the dimensional analysis. Okay, so in detail we'll discuss about the models and a prototype. Model is a replica of an actual structure. Prototype means actual structure what you are going to construct on site. It could be a canal regulator, canal turbine, or a dam, barrage, anything that is the actual structure. But the replica of those structure what you make in a laboratories, those are called as a models. To study the models and making and construction of a model, you use the dimensional analysis tool to study about the models. That will help you in this aspect. Okay, that is, model investigation is also a technique which is used to predict the behavior of or performance of the actual structure. Means in model itself you will come to know how exactly the actual structure behaves. Means after construction of a dam, how it behaves, or after construction of a canal, how it behaves, or after construction of any canal regulator, how it behaves. That you will come to know well in advance while studying the models. uh, that is what we call as a model investigation, and it is also a technique which is used to predict the behavior or performance of the actual structure or a prototype in advance. So this investigation is also based on the dimensional analysis. Thus, for model investigations, a knowledge of dimensional analysis is a prerequisite. So you must have a knowledge about the dimensional analysis for the study of about models. Okay, so this is some of the advantages of a dimensional analysis where it will be used. So again we'll discuss about the model prototype, how it will be applicable, and how to take the dimensions of different variables. So those all things we'll discuss later. So the objectives of the dimensional analysis here are just you try to understand here: develop a better understanding of dimensions. Okay, develop a better understanding of dimensions, units, and dimensional homogeneity of an equation. Okay, so let us first understand what do you mean by dimension, then what do you mean by units, and what do you mean by dimensional homogeneity of an equation. So develop a better understanding of our dimensions, units, and dimensional homogeneity. Then we'll understand one by one what do you mean by dimension, what do you mean by units, and what do you mean by dimensional homogeneity later. Okay, then understand the numerous benefits out of dimensional analysis. So you will be having a lot of advantages by using the dimensional analysis. Again, we'll discuss it later. These are the certain objectives we are setting before studying the dimensional analysis. So okay, know how to use the method of repeating variables. Again, this is a word is important, repeating variable. Then identify non-dimensional parameters. There are dimensionless parameters. How to identify these dimensionless parameters? What are the significance of these non-dimensional parameters? So to know about this dimensional analysis helps. Then again, understand the concept of dynamic similarity and how to apply it to the experimental modeling. So dynamic similarity is very, very important. So dynamic means it's related to a force. Similarity, that is similarity between a model and a prototype. What similarities the model and a prototype is having, because you are making a model of a dam in a laboratory. What similarity it is having with actual structure. To study that similarity laws, you require a concept of dynamic similarity, and how it will be applied for experimental modeling. Means whatever the model you are making in the laboratory, how it can be applied. That study you can make through a dimensional analysis. These are the objectives of dimensional analysis.
Yes, sir.
Okay. Now, let us understand what is the dimension. What do you mean by dimension here? As I told yesterday, to write the dimensions of any physical quantity, you have to remember the two things. Can anyone tell what are the two things you have to remember?
Formula and unit.
Yes, formula and its units. Correct? Units. To write the dimensions of any physical quantity, you have to remember, you have to know about its formula or its definition. You have to remember. Okay, so before writing the units, you have to define, before writing the dimensions of any physical quantity, first let us define about a unit. So unity means what? It is a standard in terms of which various physical quantities are measured, or you can say it's a way to assign a number to that dimension. It's a definition of unit. Let us look at this example here. I have taken a scale here, and on this scale it is marked a length here. But how we measure a length? We measure a length. See here I have written as a 3.2. So if I write simply 3.2, does it have any meaning? It doesn't have any meaning. So you should assign it with the units. That centimeter represents what? An unit, or you can say it is a meter, kilometer, feet, whatever. So it means a way to assign a number to that dimension, or you can say it is a standard in terms of which various physical quantities can be measured. Okay. So here again the dimension, how will you define a dimension? Can anyone tell definition of dimension? It is a measure of physical quantity, but a definition is the expression for a derived quantity. The expression for a derived quantity in terms of primary quantities is called as a dimension. The expression for a derived quantity in terms of primary quantities. Okay, again I'll come to that, what are primary quantities and what are secondary quantities. Okay, just unit is a standard in terms of which any physical quantity can be measured, and dimension means it's an expression for a derived quantity in terms of primary quantities. Then again we'll discuss what are primary quantities and what are derived quantities in the next slide. Okay, so I'll go to the next slide. Okay, so here fundamental and derived dimensions. Okay, so here there are two types, the fundamental and derived quantities. So fundamental dimensions, here there are 7 primary dimensions here. See here, there are 7 primary dimensions. Which are those? Those are mass, length, time, temperature, electric current, amount of light, and amount of matter. So these are 7 fundamental dimensions, or you can also call as a primary quantities or fundamental quantities. And these 7 are independent quantities. They don't have direct relationship between these dimensions. These all are independent. They are called as a fundamental quantities or primary quantities. Okay, so out of 7, whichever is applicable to us, or this subject point of view, we take only those quantities or those primary dimensions for our study here. Okay, there is no direct relationship between these dimensions, therefore they are called as a fundamental dimensions or fundamental quantities. Okay, these are called as a fundamental dimensions. Then there are 2 systems for fundamental dimensions generally we use. They are MLT system and also called as a FLT system. One more is FLT system and MLT system. MLT system means what? Mass, length, and time. Okay, so mass, length, and time. Even FLT system, F means a force, length, and a time. Okay, so most of engineers prefer to use MLT system, and we also follow the same thing. We also follow the MLT system only, and instead of using FLT system, most of the engineers will follow MLT system only, and we also follow the same thing. Then the derived dimensions means what? All non-primary dimensions can be formed. Non-primary, I am highlighting, non-primary dimensions can be formed by some combinations of 7 primary dimensions. Thus they are called as a derived dimensions. Derived quantities, velocity, force, and volume, etc., are called as a secondary quantities or derived quantities. Okay, and primary quantities are independent of quantities. They don't have any relationship among them. But secondary quantities or derived quantities, the quantities which are expressed in terms of the fundamental or primary quantities, they are called as a derived quantities or secondary quantities. Example: velocity, force, volume. If you want to express a velocity, you can take here. If you want to express a velocity, how you can write a velocity? Can anyone tell? V equal to what? Meter per second. Unit is meter per second, but meter I can write in terms of a length, and second time. So how I can write a dimensions? I can write a dimension M0 L1
T minus 1.
But now can you tell me what is MLT now?
Mass, length, and time.
Mass, length, and time. Correct. But these are called as
Dimensions.
No, fundamental dimensions or primary quantities. Now, with this, how you can define derived quantities? The quantities which are expressed in terms of fundamental or primary quantities are called as a derived quantities. Okay. Again, with this, how you can define the dimensions? The expression for the derived quantities. Derived quantity is what here? Velocity is a derived quantity. Velocity is a derived quantity, but the expression for the derived quantities in terms of what? Fundamental quantities is called as what? Dimension.
Yes, sir.
I hope you all understood. Here velocity is a secondary quantity, but this secondary quantity we're expressing in terms of fundamental quantity, they are MLT format. And this is what we call as a dimension, and these dimensions we generally represent in a square bracket. We write in a square bracket. When it is written in a square bracket, it means the dimension of that particular quantity is being considered. The dimensions of that particular quantity is being considered. That is the meaning of square bracket. Okay, you can write in a square bracket. So I'll repeat it once again. The fundamental or primary quantities are independent quantities, like 7 primary quantities. They are mass, length, time, temperature, electric current, amount of light, and amount of matter. There is no direct relationship between these dimensions. Therefore, they are called as the fundamental dimensions or fundamental quantities. Again, the derived quantities or secondary quantity means the quantities which are expressed in terms of fundamental or primary quantities are called as a derived quantities, and the expression for the derived quantities in terms of primary quantities, expression for a derived quantity in terms of a primary quantities are called as dimensions, is called as a dimension. I hope you understood this one. Okay.
Yes, sir.
Similarly, you can write for the force, you can write for the volume, you can express in terms of primary quantities. Force, volume, and other things will represent the derived quantities, and expression for derived quantities in terms of fundamental quantities are called as a dimension of that physical quantity. You have to write in a square bracket. When you are writing in a square bracket, it means it is the dimensions of that particular quantity is being considered. Okay. I'll move to the next slide. Just look at these primary dimensions. So here primary dimensions and their associated primary SI and English units. Okay. So here, just a minute. Here, see the dimensions here. There are 7 primary dimensions or primary quantities: mass, length, time, temperature, electric current, amount of light, amount of matter. Symbol is given here. Mass is represented as M, length is L, time is T, temperature is capital T, electric current I, amount of light C, and N. See, look at the SI units as well as the English unit. In SI unit, mass is represented as a kg, and in English unit, it is represented as a pound. And length is measured in meter, and time is measured in a second. Even length in English unit is measured in a foot, and time second in both the units, both the system. And temperature again in SI system it is a Kelvin, and in English unit is measured as a Rankine. So electric current, it's an ampere. Both the system it is an ampere only. Amount of light again candle, same candle here also. And amount of matter is a mole, and here also a mole. Okay. So generally we'll follow the SI system only. So we'll omit this one. So we'll go for SI system only. You all can also follow the same thing, SI system only. And we'll write we'll express the quantities in terms of MLT format. MLT format. We'll follow the MLT format only. Okay. So just here an example given here is a force. So force, here is a force. This force, you all know the definition of a force. So how the force can be written? Mass into acceleration. Mass into acceleration, right? But the unit of mass is what? What is the unit of mass? Kg, correct. Then what is acceleration? Into, what is acceleration? It's a velocity by time, or rate of change of velocity, correct? It's the rate of change of velocity is called as acceleration. So I can write velocity by time. Velocity by time. Okay, velocity by time it is. Okay. Now, kg is a unit of what? Mass. Then I can write m, correct? But what is velocity? Again, before writing that one, just a minute. Okay, first again we'll again reduce this equation. We'll write it kg. I'll keep as it is kg. Yes, can you tell me kg? Yes, kg. How will you write velocity?
Meter per second.
That is only meter per second. No, length by time can write. It can be written length by time. Is it length by time? Yes or no?
Yes, sir.
Because the velocity is measured
Yes,
in
sir.
meter per second. So meter is the unit of what? Length. Correct? So I can write length by time already in a denominator. Time is there. Okay. Then how I can write kg length divided by what?
T square times
T
square.
square. Okay. So after writing like this, then you can easily express this one in primary quantities. That is dimensions you can easily write. Then kg, how you can write? Mass, m. M1, right? Then L, L1.
L1
Next,
T minus 2.
T minus 2. Okay. Correct. Then after writing this one, you have to write in a square bracket like this. It means you have considered the dimensions of a quantity. Quantity is what here? Force is a quantity. That is a physical quantity. You have considered the dimensions of that one. Okay. So you should remember these dimensions quickly. So later when we solve, when we analyze certain problems, there you should remember the dimensions of certain quantities directly. Okay. So this is how we can write the dimensions of any physical quantity. Even you can write the dimensions for the surface tension. Just you try it and check this dimensions of surface tension. All of you just check it out in your notebook. You can take the surface tension. Surface tension is nothing but force per unit length. As I said, if you want to write the dimensions of any physical quantity, either you have to remember its unit or its formula or the definition. Okay, force per unit length is a surface tension. So again, force. What is the unit of force? What is the unit of force? Newton. Divided what is the unit of length? Unit of meter. So can you tell me what is the dimensions for surface tension? Dimensions for surface tension quickly. You can write it on your notebook and can tell me dimensions for surface tension. I'll take this one. Can you tell me dimensions for surface tension?
M1 L0 T minus 2.
1 minute. I'll write here M1
L1 L0
L0
T minus 2.
T raised to
T
minus 2.
minus 2. Okay. Yes, this is what we call as a dimensions for surface tension. Anyway, it is here. It is there, but here they are not taken L term, but you need to consider all three terms. But you have to write the powers of the primary quantities. Powers M1, L0, T raised to minus 2 like this. So L0 means we are not that the term is not present here. Okay. So I hope you understood this one. This is what how to write the dimensions of any physical quantity. So this is a picture showing you that surface tension of water over which the insect is walking by utilizing the surface tension force. Okay. Next. So these are the some quantities I am giving you all as a homework. So here certain quantities are been given here: length, area, volume, time, velocity, acceleration, gravitational acceleration, frequency, discharge, force or weight. So these all we use frequently in this particular module: a length, area, volume. So we use it frequently. So can you tell me what is the length unit? Length unit is meter. What is the length unit?
Meter.
Meter. Okay. Next, what is the area unit?
Meter square.
So you just add one more column here. Just you write here unit like this. Unit. So like a meter. So its area is a meter square. What is volume?
Meter cube.
Meter cube.
Time.
Second.
Second. Like this. Velocity.
Meter per second.
Acceleration.
Meter per second square.
Per second square.
Correct. Meter per second square. Gravitational acceleration same. Meter per
second square.
second square. Frequency.
Lambda.
Lambda.
Per second. Correct?
Yes, sir.
It's a per second. Frequency
Yes,
per
sir.
second. That's what we call hertz. Okay. Like this. Per second. You have to write this one. Per second. Then discharge.
Meter cube
per second.
Meter cube
per
per
second.
Per
second.
second.
Okay, right. Force or
Newton.
weight,
Newton.
Newton. Right. So like this, if you write the units of any physical quantity, you can easily write the dimensions of that quantity. See, length meter, meter means L. Area meter square means L into L. So volume can be written as L cube, means L into L into L. So here M0, T0. Then time, it's a second, it's a T, but M0, L0, we can write T1. Like a velocity, it's a M0, L1, T raised to minus 1. Here I given in both the system, MLT system as well as FLT system. Okay. Again, these are again some quantities I am giving here. So like that, how I written the units. So you all can note it down and write the units for these quantities. Okay. Can you tell me what is the unit per power?
Joule.
Watt.
Watt, sir, watt.
It's a watt. Watt, how will you define a watt, or how you can reduce the watt? Watt means what? Work done per second. Correct? Work done per second is a watt.
Yes, sir.
As I said, if you want to write the dimensions of any physical quantity, either you have to remember its unit correctly or its formula. Work done per second is correct, but work done, how will you measure again work done?
Force multiplied by distance
Correct,
divided by
correct,
time.
correct. Force multiplied by distance divided by time. Again, so someone said force multiplied by distance divided by time. Again, you have to reduce. What is the unit for force? Newton.
Newton.
What is the unit for distance? Meter.
Meter.
What is the unit?
Meters.
Time is time.
Second.
Keep as it is. Okay, second. Okay. So Newton meter per second is what? Watt. But again, Newton, you have to reduce it Newton. Again, kg meter per second square. Correct? Then into meter divided by second. Is it correct?
Yes, sir.
Okay. Now after writing this one, just you check it out. Can anyone tell what is the dimensions of this one? Anyway, it is here. Just check it out. Cross verify it. Don't look at here and tell, but you have to check it out once. See, I written completely. Kg means mass. Then check it out. Mass. Meter. Check it out.
Correct, sir.
Is it
Sir,
correct?
it is correct.
It's correct. No. So like this, you have to write the dimensions of any physical quantity. So similarly, you just go through these quantities, write the dimensions, and just write per dimensions of these quantities. Just you write the units and just check it out.
Yes.
These dimensions. Because next, whatever the types of dimensional analysis I am going to discuss next class. So these will help you very much there. Okay. So that's why I'm telling you. So you have to remember each and every quantity dimensions along with its units. Okay. Then now, yesterday I was discussing about dimensional homogeneity. So again, after studying units, dimensions, and how to write the dimensions of various physical quantities, what do you mean by dimensional homogeneity? As I was discussing in objectives there, I told you there are three terms: dimensions, units, and dimensional homogeneity. Have you remembered in objectives term? As I was highlighted, I told you I'll explain it later. Have you remembered while explaining about objectives? See, the dimensional homogeneity is a very important dimensional homogeneity. So what are the advantages of this dimensional homogeneity? Means if you want to check the correctness of any equation, whether the equation is right or wrong, you can say by writing the dimensions of that equation quantities. So here I have taken one example here. Just you look at the example given here. I given apple, again plus apple plus orange. Apple plus orange. So what is the end product you get here? Then if I add apple plus orange, what is the answer?
Double apple plus orange.
Yes, 2 apple plus 1 orange you will get. Correct? 2 apple plus 1 orange. I cannot write 3 apples. It's wrong. You can't add apple and oranges. Right? Okay. That becomes, now this equation becomes heterogeneous equation. So if you want to define a dimensional homogeneity, means whenever you take any equation, its LHS side and RHS side dimensions should be identical. Then we call it as a dimensional homogeneity. Okay, it means every additive term in an equation must have the same dimensions. An equation is called as dimensionally homogeneous equation. Okay, so here every additive term in an equation must have the same dimensions, then that equation is called as a dimensionally homogeneous equation. An equation is called dimensionally homogeneous when we call it as a dimensionally homogeneous equation if the fundamental dimensions, can anyone tell what are fundamental dimensions? What are fundamental dimensions? Yes, mass, length, and
temperature.
Length,
yes,
time,
correct.
temperature, amount of light.
Correct. These all are called fundamental dimensions. So they should have the identical powers of MLT or FLT on both the sides of the equation. Then that equation we call it as a dimensionally homogeneous equation. Just I have taken a one example here. This V equal to U plus AT. This is the equation of motion. So now, can you tell the dimensions for velocity quickly? Dimensions for velocity.
M1 L0 T minus 1. M1 L0 T minus 1.
L0 T minus 1. You all can agree for this one?
L1 T raised to minus 1.
Sorry, 1 minute, it's wrong. Where
Yes, sir. M0 L1.
Wait, it is wrong here. M0, no? Correct?
Yes,
M0.
sir. M0
M0
L1 L1 T minus 1.
Correct. Okay. Now this side, coming to this side. What is U? U also a velocity. U also velocity. Can you tell me the dimensions? Same, no?
Same, sir.
M0 L1 T raised to minus 1. Correct? Is it right? Okay.
Yes,
plus. What is A? Acceleration. What is the dimensions? What is the dimensions for acceleration? Quickly.
M0 L1
M0 T minus 1.
M0 L1
T raised to
minus 2. You also write your in your notebook. In your notebook you also write it. Okay. Then T is a time. I can write it T. Correct? Now I'll add this one. I'll keep this term as it is. Just look at here. I'll write M0 L1. Now T raised to minus 2 and here is T1. Tell me because it is a multiplying here. Tell me.
T raised to minus 1.
T raised to minus 1. Correct? Now just look at the dimensions on both sides, LHS side and RHS side. See here I'm rating it is if the fundamental dimensions have identical powers of MLT and FLT both the sides of the equation. So here M0 is there here on LHS side. Look at the LHS side. M0 is there.
Yes, sir.
Is there or not?
Yes,
See
sir.
look at RHS side. RHS side we have M0 L1 T raised to minus 2 times. Then I can write it 2 into M0 L1
T raised to minus 1.
T raised to minus 1. Okay. Forget about this numerical value. 2 is forget it about this one. You don't want to add this one. Just compare the powers of MLT. What is M here? What is the power of M here? LHS side? 0. What is the power of M on the RHS side?
0.
Yes. What is the power of L in LHS side?
1.
1. What is the power in RHS side? L.
1.
Same. What is the power of T in LHS side?
Minus 1.
Minus 1. What is the power of L in RHS side?
Minus 1.
Minus 1. So both the side the powers are identical.
Sir.
Yes, sir.
Then this equation is called as a dimensionally homogeneous equation, and this equation what we call this is the correct equation. In sometimes what will happen, you won't get the same powers in some certain equations, then that equation is called, it is not dimensionally homogeneous equation. What is the advantages of checking this one? The dimensions will help you check the homogeneity of an equation. I hope you understood the concept here. I hope you understood the concept here.
Yes, sir.
Even you can check this one, which one, we have what is that formula called as Darcy's friction equation. What is that friction equation? What is that one?
4FL V square by 2G.
Yes.
2GB.
HF equal to 4FL V square by 2 2GD. You can check this equation whether it is correct or not just by writing the dimensions. So HF means was it is a frictional loss, frictional head. Okay, so this will head will be measuring in what, in terms of meter or a millimeter or a centimeter. F is what, coefficient of friction. It doesn't have any dimensions, it's a coefficient. Then M0, L0, T0. Then L is what, that is L1 only. V is velocity meter per second, G is meter per second square, D is in meter. If you substitute all the dimensions here and simplify it, you should get the powers of fundamental dimensions same in both side, LHS side as well as RHS side. Can you check this equation? All of you can note it down, this equation, and check it whether this is dimensionally homogeneous or not. Can you check this equation? Are you taking this formula?
Yes, sir.
Just take
Yes,
this
sir.
formula and check it. Even you can check which is that formula, discharge through rectangular notch. What is that formula? Q equal to 2/3 of CD root of 2G
2H.
L
H raised to 3 by
H raised to 3 by 2. Okay, so in this one, just let us forget about this 2 by 3 and CD. CD doesn't have any unit, it's a unitless, leave it. And root also, square root also, leave it. Just check it out, the powers of the this fundamental dimensions, both side, LHS side as well as RHS side. You should get the same powers, then only we say that equation is called as a dimensionally homogeneous equation. That's why given as example here, you cannot add apple and orange here. Apple plus apple, you should get apple only on the RHS side. If you add apple plus orange, then you will get apple plus orange only. Okay, you cannot get the orange cannot become a apple. Okay, so this cannot be called as a dimensionally homogeneous equation. And the dimensional homogeneous equation is one which has same dimensions both the side, LHS side as well as RHS side. Likewise, you can take any example, you can check it out. You can take the discharge equation also, you can check it out, or else you can take the motion equation. Which is that motion equation? S equal to ut plus half at square. You can take this also, S equal to ut plus half at square. You can check the equation. So this is the advantages of having a dimensional homogeneity or dimensional analysis here. You can check any equation whether the equation is right or wrong. You can check. Okay, if you are getting LHS equal to RHS, that is the dimensions on both the side, then you can say this is the correct equation, and this is what we call as a dimensional homogeneous equation. Okay, you can check the any equation. Okay, I hope you understood the concept of dimensional homogeneity. Dimensional homogeneity, and you can take this as a very important for the examination point of view. Many times they are asking you define dimensional homogeneity, give an example, or what are the advantages of dimensional homogeneity. So can anyone tell what are the advantages of dimensional homogeneity?
Sir, easily identifiable of dimensions.
Correct, easily identifying dimension, and also the very important word is to check the correctness of an equation. Whether this equation means, suppose if you are doing some research work, in a research work, suppose if you have obtained one equation, that equation whether it is right or wrong, if you want to tell that whether it is right or wrong, you can write the dimensions of those quantities and check LHS and RHS. If you are getting the same both sides, then you can say this is the correct equation. If you are not getting the same dimensions on both the sides, then it is a heterogeneous equation, or you can call it as a non-homogeneous equation, or somewhere you went wrong, or you can call it as a empirical formula. Based on certain experience, you have obtained certain formula, and that formulas are called as empirical formula. These are called as theoretical formulas or scientific formulas which are being obtained through experimentation results. Okay, so this is how we can utilize the dimensional homogeneity in case of checking the equations of any phenomenon. I hope you understood the concept here, all of you. Dimensional homogeneity.
Yes, sir.
Please note it down. This is very important examination point of view. What are dimensional homogeneity? give an example. You can give any example. Take an equation of motion or HF equal to 4FL square by 2GD. Through these equation, you can prove whether it is dimensionally homogeneous or not. They will ask you just to give an example. You can give any example. You can take a Darcy equation. You can take the discharge equation of a rectangle, triangle, or a Venturi meter, orifice meter, motion equation, or a pressure drop equation. Any equation you can take and check it and confirm that this is a dimensionally homogeneous equation. Okay, any doubt here? Any doubt here?
No, sir.
No, sir.
Okay.
No, sir.
But to check the dimensional homogeneity, you should have a knowledge about writing the dimensions. As I explained previously, you should write the dimensions of any physical quantity. Either you have to remember its units or its formula. Unless and until you remember its units and formula, you cannot write the dimensions of any physical quantity. Okay. So through this, we can check the dimensional homogeneity. It helps you checking the correctness of equation. Okay. Just as I was taken this example here. Just a minute, there is this one. Okay, so let us take this example here, just change in the discharge. This example here, change in energy, that is initial energy minus final energy, that is change in kinetic energy example we have taken here. So this example just is discussing to prove the dimensional homogeneity, that is energy formula is what, force into length, then the energy, finally we get the dimensions of energy. Similarly, this is also potential energy. Again, potential energy also get the same dimensions. Again, the change in kinetic energy, again it gets the same dimensions. Finally, whenever you write the equation for that, dimensions of that equation, the dimensions of that equation is same in both the side, LHS as well as RHS side. Okay, so here LHS and RHS are same, then this equation is called as dimensionally homogeneous equation. This is called as a dimensionally homogeneous equation. Okay, the change in energy. Okay, just you can check by taking the any equation, anything, you can check dimensional homogeneity. Okay, so you can just continuation of dimensional homogeneity. You can take the Bernoulli's equation also. You can check Bernoulli's equation also. You can check the homogeneity of an equation. Take this, all of you, this as an example to check, verify that each additive term in the Bernoulli's equation has the same dimensions. So what are the dimensions of the constant C? Means you have the pressure energy here, kinetic energy here, and potential energy here. Finally, you are getting a constant here. What is the dimensions of this constant? You have to tell. So you all can take this example and we'll discuss it tomorrow's class. So what are the whether it is dimensionally homogeneous or not, you check it and tell me that tomorrow. Can you take this as an example?
Yes, sir.
Yes, sir.
Okay, please,
Yes, sir.
take this as an example. We'll continue tomorrow. We'll wind up the session here and take this example and check the dimensional homogeneity. Okay, so tomorrow we'll continue the same thing and then we'll discuss about the types of dimensional analysis. Please practice by writing the dimensions of any physical quantity and take any equation and check whether it is dimensionally homogeneous or not. And again, we'll discuss some advantages of dimensional analysis, where it will be applicable and how it can be used for analyzing various quantities and all. We'll discuss it tomorrow. But unless and until you don't know how to write the dimensions of any physical quantity, you will not understand this module. I'm repeating it once. Okay, so I hope you all understood the writing the dimensions of any physical quantity. Okay, so can you practice it today, all of you?
Yes,
Yes,
sir.
sir.
Please practice of any quantity writing the dimensions, then check the homogeneity of any equation. Okay, right. If you have any doubt, you can ask.
No, sir.
Otherwise, you can leave the meeting.